As children, we read in fairy tales of enchanted forests filled with trees that have human faces, trees that can talk, and, on occasion, walk. I'm here today to tell you that while most of us have dismissed these stories as mere fantasy, they do contain within them a hidden wisdom. A wisdom that, if embraced, could help shatter the illusion of forests as inert, inanimate thickets, and return to us the image of the ethereal woodland, an image that, despite its veracity, seems to be worn away by the cynicism of adulthood. Over the course of this speech, I will delve into the marvelous world of trees by exploring where they come from, how they thrive, and how they are threatened by modern humans. By the end of this discussion, I hope that the trees of the world are as lively and animated to you as they now are to me. With this viewpoint in mind, we might be able to better understand the problems modern forests are facing, problems like deforestation, climate change, and forest fires, and most importantly, how humans can help. And on that note, I shall begin from that which all forests begin: soil. While it may not seem like much, the soil that lines the floors of old-growth forests is an unimaginably complex product of many years worth of biological decomposition and erosion, through which plant matter is slowly degraded by microorganisms until it is converted into the highly fertile, nutrient-dense substrate known as humus. This is the kind of soil that we see scattered about forests today. And in healthy forests, the humus becomes deeper and richer over time, so that growing conditions for trees constantly improve. Besides the soil itself, there also exist marvelous organisms that live within the soil. To be frank, these organisms, with their small size and nearly unpronounceable Latin names, are not all that attractive. It is quite clear that mountain pine beetles, millipedes, and pseudocentipedes are not nearly as engaging to the public as dolphins, kangaroos, or panda bears. But these small organisms make up for in their size with their indispensable position in the food chain. They break down organic matter, turning unyielding plant fibers into soft, nutrient-dense humus, making them so valuable to the continuation of forest ecosystems that it would not be an exaggeration to call them the terrestrial equivalent of plankton. On the topic of indispensable organisms, there exists a branch of life form that one could call biological fence-sitters, and that can either be considered animals or plants. The entities that I'm referring to are known as fungi. Although fungi can't photosynthesize food for themselves and rely on organic connections they form with other living beings to survive and reproduce, they are still immensely important to forest ecosystems. Now, so far, I've discussed humus, microorganisms, and now fungi. Finally, we're ready for the trees. Over millions of years, they've evolved their root structures to be as efficient as possible when it comes to absorbing moisture from the soil. Different tree species have their own specialized structural adaptations that allow them to proliferate in their own ecological niches, with each generation getting closer and closer to the limits of efficiency and parsimony. As a result of this evolutionary inclination, thousands of independently evolving tree species from all over the world have come to pair up with fungi. To be clear, the relationship between plants and fungi is not always a symbiotic one. There are cases of fungi expanding their underground cottony of organic connections, known as mycelium, to destroy and consume entire forests. On the other end of the spectrum, there exist examples of amicable relationships between fungi and trees, such as the oak milkcat mushroom combination. This relationship is initiated when the fungus bores its threads directly into the fine hairs that line the oak's root system. With their combined biomass, the oak is able to absorb water and nutrients from a much larger surface area than it would have been able to otherwise, allowing it to contain twice the amount of life-giving nitrogen and phosphorus than plants that tap the soil with their roots alone. The bonding process is highly unique to the tree and fungal species in question, which is why each species of tree has a distinctive fungal species that it pairs up with. Fungal root systems can span multiple trees and many different species of fungus, facilitating the exchange of nutrients and information between different plant species, which has been colloquially called the wood wide web. Perhaps one of the most intriguing phenomena that occur across this web is the seemingly altruistic tendency for trees to share nutrients and support their neighbors when threats are detected. For example, during one of his excursions, German forester Peter Willeben came upon the stump of an old beech tree that had been cut down hundreds of years before. To his surprise, when he peeled back the layer of bark that covered the stump, he discovered a layer of bright green chlorophyll beneath, showing that the tree was still alive, despite having no leaves to photosynthesize with. Upon further study, he realized that trees frequently exchange glucose, water, and other vital compounds between one another in order to contribute to the collective survival of the forest ecosystem. Trees also use this wood wide web to exchange information on encroaching threats, one such threat being the common bark beetle. When these beetles find young or ailing trees, they use their specialized mandibles to burrow directly into the tree bark until they reach the nutrient-dense cambium at the center of the tree. There they will lay their eggs, from which voracious larvae will emerge, spelling doom from the tree as they devour it from the inside out. To avoid this fate, when a tree detects the presence of bark beetles on its trunk, it will send out electrochemical signals to the surrounding tree roots and fungi, requesting aid from neighboring trees for water and glucose, which it will use to flood its trunk with tree sap, produce more phytonicides, and regenerate any holes left in its bark. It might be surprising to learn that trees work so hard to defend one another in this way, considering the fact that much of humanity's modern understanding of trees is built around the idea that trees will fight and compete for light and space. But this is a gross misunderstanding of how forests function. Trees do compete, but rarely to the point where they will pose a significant threat to one another. Forests are self-perpetuating systems. They maintain a stable internal microclimate, produce nutrient-dense humus, and capture particles in the air. The system only works if a large number of healthy trees are working together, living in close proximity, keeping the precious humus layer on the forest floor cool and moist. When the system is broken, like when large numbers of trees are killed off, the forest ecosystem fails. All of this information is meant to illustrate how complex forest ecosystems are, and how humans have historically been either willfully or genuinely unaware of their impact on the environment. This statement becomes especially relevant today, where there currently exists a massive wildfire burning across the West, which has collectively scorched an area equivalent to the size of Connecticut and is still burning. In order to stop this fire and prevent future fires, it is important to understand how this fire started and why it still continues to burn with such intensity. The obvious culprit is climate change, which has dried out wooded regions and made them more flammable. But there are other lesser-known factors that also contribute to intense forest fires, such as how humans quickly put out minor forest fires as soon as they spring up. These misguided efforts ignore that small forest fires are needed to burn away brush and kindling that collects on the forest floor. These fires are minor and very common, so much so that some tree species have evolved methods of using these fires to their advantage. Jack pines are one such species. As they've developed cones that, when exposed to high heat, pop open, dispersing seeds onto a bed of nutrient-dense ash, clear to vegetation. Humans put out minor forest fires as soon as they spring up, leading to a situation where massive amounts of flammable material has accumulated on the forest floor. When this situation is paired with high heat caused by climate change, forests that would have at one point survived or even thrived in the face of fire are now threatened by its destructive force. With this in mind, the Healing Harvest Forest Foundation, non-for-profit, made it their goal to break down the capitalistic relationship Americans have with their forests and promote community-based forestry initiatives that advocate for the removal of single ailing trees as opposed to the commercial clear-cutting of entire forests. This allows us to obtain lumber while still preserving the health of forest ecosystems. So perhaps next time you are gazing upon the trunk of a sturdy oak or hiking beneath the crown of an old beech, you will stop and think about the vast complexity that exists right beneath your feet, a complexity that we risk losing if we aren't cognizant of our impact on the environment. So let us pay more attention to what the trees of the world have to offer. While we might not see the expressions in their cracked bark, hear the conversations unfold across their gossipy roots, or witness their harrowing journeys from seed to verdant tower. If I had to leave you with one message, it would be that the trees of the world are just as lively as we are, and should be treated with the same care and humanity that we reserve for each other.